In section 3, we're going to look at what are called polynomial functions. So we're going to look at evaluating polynomial functions, and then we are going to finish by looking at general shapes of graphs of polynomial functions when we look at end behavior, which will be the little bit harder portion of this lesson. So I don't want it to be too confusing, but we are talking about a polynomial in one variable. So that means I'm only going to be dealing with one variable. And everything that we've been dealing with up to this point has really been polynomials. Now we're just using function notation. So there's some different kinds of polynomials that we've dealt with already. A constant polynomial, this is just a value. So we could say that a constant polynomial function would be something like f of x equals 12, or f of x equals, say, -5. These would all be constant polynomial functions. A linear polynomial function, well, that can be in the form of a line. So if it's in the form of y equals, f of x equals, mx plus b, then that would be considered a linear function. Quadratics are what we dealt with last chapter. If you remember, in terms of a quadratic, the highest power was always 2. And now what we're getting into is cubic and general polynomials. So a cubic, with the highest degree, would be to the third, quartic, or something to the fourth power, fifth power, sixth power, and so on and so forth. And they put it in terms of a general, what the general form of a polynomial looks like down here at the bottom, which gets maybe a little confusing when you look at it. But that's really what we're dealing with, is polynomial functions with a degree 3 or greater is what we're going to come into contact with most of the time. So in this example down here at the bottom, they want you to state the degree and the leading coefficient of each polynomial in one variable. If it's not a polynomial, then you just have to explain why. You wouldn't have to state the degree or leading coefficient if it's not a polynomial. So I'm going to start out right away, 1a. This one is not a polynomial. And the reason for it is I have a variable that is in the denominator. Really, we could rewrite this as 5x cubed minus 4x squared minus 8x plus 4x to the negative first. So in other words, you can't have x in the denominator, or you can't have negative exponents. That doesn't make it a polynomial anymore. So that's all I would need to state for 1a. If I go to 1b, this one is a polynomial. It's in its general form already. So then they want you to state the degree and the leading coefficient. Well, the degree is the highest power that you see. So this one's to the 6th, the 4th, the 3rd, and this is just our constant term at the end. So the degree of this polynomial is 6, and the leading coefficient on this is the coefficient out front, which is the value of 5. They may ask you to come up with what is the leading term. The leading term is the whole thing put together, 5x to the 6th. And it may ask you, what is the constant term? Well, the constant term is just the constant value, which would be -14. 1c is similar. It is a polynomial. The degree of this one would be the 6th degree, because that's the highest power that you should see. The leading coefficient would be -1. Your leading term would be -x to the 6th, or -1x to the 6th. And then your constant term would be your value of 3.